Good day, everyone. So, I would have wanted to be with you virtually in real time, but then sometimes internet connectivity is not going to it's not cooperative. So that's why I'm preparing a recording in case my connection is not going to cooperate. Okay, so I'm going to discuss aspects in making a statistical analysis plan. So just very basic, how you're going to prepare your statistical analysis plan for your research. Although the time allotted for me is 2 hours, but as much as possible, I'm going to finish this in less than an hour because I know we have a lot of things to do. And then sometimes our attention span is going to be very short because of a lot of things in mind. Okay, so I'm Dr. Lisa Lorena Hala. I am a technical consultant also of the MCIAA for their customer satisfaction survey since 2020. Okay, so there are questions in mind that we need to answer when we are going to look into or we are going to plan our data analysis. So first thing is, or although this is not in order, you can ask them, not in order really, but then you need to answer what do you really need to know. So that's one thing that you need to consider when you are going to plan your statistical analysis. How does the information need to be presented? So how you're going to present the information that you have gathered? What data points do I therefore need? So what do you really need? The data points. And does the information help me respond my original questions or your research questions? So these are the basic things that you need to consider when you are going to plan for your analysis plan. So actually, if you are going to equate an analysis plan, it's just like a blueprint or it's a roadmap. So when you say roadmap, there are aspects that we need to consider. So I'm going to specifically tell you these basics in order for you to come up with a sound analysis plan. Because if you're going to remember, your research, although you have a very good intention objective in your research, but then your analysis plan is not as good as that, then it's nothing. So when you are going to look into or you're going to plan your roadmap for statistical analysis, you have to clearly state the objectives. Of course, you have your objectives already when you are preparing for your protocol. So you have to state your objectives and hypothesis if you need to hypothesize something, if it is for if you're doing some inferences or you're planning to make some inferences about the population, or if you don't need to state the hypothesis if you are simply profiling your patients, for example. So that's purely descriptive, so you don't need to state your hypothesis. You have to identify also the data set to be used, what type of data set or what type of data you're going to collect. You have to be clear also of your inclusion and exclusion criteria, what you need to include and what you are going to exclude based on the data set that you have. And you have to clearly state your research variables. So your research variables can be seen through your statement of your objectives, what you need to know, how are you going to answer these objectives, what you need to collect. So these are your research variables. And you have to state the statistical test or hypothesis and the software for statistical analysis. So there are a lot of softwares that you are going to choose from, in which I'm going to mention later on. And then creating the shell tables, or we are familiar with that. We do not call it the shell tables, but we call it the dummy tables. So let's go with this one by one. In stating your research questions or your objectives or your hypothesis, so all the objectives must be clearly stated. And it should not be double-barreled. So I have observed that, although this is already discussed previously, but then I have observed residents and some fellows that when they state their objective is double-barreled. A lot of things, a lot of variables in one question. I mean, it's a no-no. You have to be specific, each one of it. So it's there should be some one question or one topic for each of the statement. And of course, you knew already the SMART. And if you are going to hypothesize something that is based on your statement of objectives. The data set. So the data set that will be used for statistical analysis must be described, and important aspects of the data set should be outlined. So that includes who is the owner of the data set, if you are getting it from the website of the PSA, or you are getting it from the website of the WHO, or you are getting it from the medical records of the hospital or the institution you are connected. So you have to take note of that. And how would you get access to the data set? If it is the medical records of the hospital, how would you get access to that data set? How the data set was checked for quality control, and in what program is the data set stored. So you have to be also wary of that. Some problems arise when we are going to look into our own medical records of the different institutions. So sometimes institutions are not very careful with the data collection, so there are a lot of missing information, and which is going to affect the integrity of your data analysis. Storage also, the usual storage or the usual form that we store our data set is through Excel, so that's very common. Or sometimes it's in SQL, Microsoft Access, or if you're familiar with the EpiInfo, it can also be stored in the EpiInfo. So for epidemiologic studies, most of their data sets are stored in EpiInfo. But most cases, in hospitals, we are storing our data set in Excel form. I have seen also data from DOH, in which we did a study on SSI. Okay, so it's in Excel form, and sometimes, if not most of the times, encoders of this data using the Microsoft Excel do not really know how they're going to encode it. There was one in which I encountered a medical doctor. Nobody has guided him how to encode. So, in one column in a Microsoft Excel, he put an information there, two informations, the age and the gender. So 18F, 25M, like that. So that would be very difficult for us biostatisticians to analyze that right away. So we need to re-encode it, separating the age and the gender. So that's also very important, that before we are going to look into this data set, we have to look into how it is being compiled. Then the inclusion and the exclusion criteria. So this guides us on what to include, and sometimes the analysis plan is very good upon submission, upon the writing of the protocol. It's very good, it's almost perfect, it's the ideal. But when you are going to start the data collection, you will come across how data is being collected, and you may encounter a lot of data which will be excluded based on your inclusion-exclusion criteria. So there is going to be a change in the analysis plan. That is why in the protocol, in the making of your proposal, it is still called a data analysis plan, because it's still a plan. But it will be finalized when you are done collecting your data and when you are done writing your final manuscript. This criteria also will guide the choice of variables included in the main analysis. So that's also very important. Then the variables. So when we are going to collect our data, of course, we will be facing or we will encounter a lot of variables. So every variable that you are going to collect for your study, you should clearly state it. And sometimes these are the variables, the variables are the ones that we are going to operationally define. I have to emphasize operationally defined because that is only used for this study, for the specific study. But those variables which are universally accepted, the meaning is universally accepted, like the variables in the diagnostic accuracy, sensitivity, specificity, you do not have to operationally define it unless you are going to make a cutoff for your specificity or your sensitivity. But then that's not usually the case that you are going to operationally define it. And this variable should be presented based on the levels of measurement or the role of the variable that it plays in the study, whether it's an outcome, a moderator variable, dependent, independent, or whether it's nominal, ordinal, ratio, and interval. So also you need to outline your variable types. That's very important. That is for you. That will serve as your guide on how you're going to summarize it and what statistical tool you're going to use in order to summarize these variables properly. And the variable type is in conjunction with your hypothesis, which would form the basis for selecting, as I've mentioned, selecting the appropriate statistical test for inferential tests. Although, it's not covered here in my discussion. So, going to the variables, we have this measurement. So, that means when we talk about measurement, that is the assigning of numbers and codes according to prior set rules. So that's how Stevens define it. So there are three main types of measurements. You have your categorical or nominal, you have your ordinal, and your quantitative variable scale. But sometimes there are also instances in which ordinal level variables are categorized, nominal. And then quantitative, they are lumped into scale if you are referring to a statistical software in which interval or ratio level variables are termed as scale. Talking about categorical measurements, they classify observations into named categories. For example, HIV status. So when we say HIV status, is either positive or negative. Or it could be sex, male or female. So sometimes there are some debates in which whether to use the term gender or sex for profiling. So if we're looking into demographic studies, they use the term sex, because when we say gender, it's some sort of role. So gender could either be LGBT, like that includes LGBT. But if we say sex, it's only two, male or female. Blood pressure is also an example under categorical variables. So you are going to classify them either as hypotensive, normotensive, borderline hypertensive, or hypertensive. Sometimes when you are going to collect your data, I have seen that separating the diastolic and the systolic BP. Okay, but then it would be very important to take note that as biostatisticians, we find it difficult to categorize them, right away. So it would be better if you're going to categorize them. Although you can include the systolic and the diastolic BP, but we can always find the weighted mean for the systolic and the diastolic, but it's important that you are going to classify them as hypo, normo, or hypertensive. Some others do not include anymore the borderline hypertensive. Variables are also in ordinal measurements. So when we say ordinal measurements, they can be put into some ranking or rank orders, or they are ordered. For example, just like the stage of cancer, there is stage 1, stage 2, stage 3, stage 4, or depending on the type of cancer, because I know that there are some types of cancer in which it would reach up to stage 6, the end stage. Also, opinion. So when you opine, when you strongly agree, or you cannot decide whether to agree or disagree, or you disagree or strongly disagree, the so-called Likert scale, they are in the ordinal measurement. But for some cases, if not most cases, some would treat ordinal level measurement variables as nominal, because naming or categories is still present in the ordinal level variables. It's not wrong when you are going to treat them as nominal also. But for quantitative measurements in which numerical values should equal spacing between them, just like in the number line, just like variables, age, because you have to measure it in years, your serum cholesterol, or the T4 cell count, that's per deciliter. Okay, so you need to put them in numbers. And I have seen also that ages, when they collect the age of the patient, when they are going to collect data, they already put them in some form of range, like 21 to 30, 31 to 40, 41 to 50, like that. It's good that you are putting them into range so that we would know who are those in between those, or how many are of age 21 to 30 or of 31 to 40. But it's after when you find the average, the weighted mean. So it is important that you are going to leave it blank, or you're going to, you are going to review the medical records, you are going to put them as is. Like if the age there in the medical record is found to be 28, so you have to really put 28. And it's up to your statistician to put them into range. Okay, so also this one, look. Okay, so let's take a look at this example so that we would understand better or on those measurements of variables, the one that we have previously mentioned. So let us have this example on weight change on heart disease. This is taken from Willett et al., the study published in 1995. Okay, so if the study investigate the effect of weight gain on coronary heart disease risk. So this includes 115,818 women 30 to 55 years of age, all free of coronary heart disease. So that is before they start the study. So this is the baseline information that They must be 30 to 55 years old, all women. Okay, so the numbers computed is 115,818, and they must not have any coronary heart disease prior to the longitudinal observation, because the study is going to run for 14 years follow up. Longitudinal. So 14 years follow up to determine whether there is a coronary heart disease occurring, so CHD occurred. And the following variables are measured. There are 3: categorical, ordinal, and quantitative. So categorical variables, this includes being a smoker, current, former, or a non-smoker. If there is an onset of CHD, yes or no. And family history of CHD, yes or no. And whether in the ordinal variable, whether if it's a non-smoker, light smoker, moderate smoker, heavy smoker. So please take note that non-smoker, light smoker, moderate smoker, heavy smoker, you have to operationally define. So how will you define a light smoker? We know that a non-smoker never smoke cigarette. A light smoker, what do you mean by that? A moderate smoker, what do you mean by that? Heavy smoker, what do you mean by that in terms of back years? The BMI, whether it's the weight is below normal, or considered overweight or obese. Or others call it underweight, normal, overweight, and obese. Sometimes also people would simply categorize them as normal and above normal. So that depends on how it is being, how you, although there is that of BMI classification, but you can always have that operationally defined that will suit the objectives of your study. And then for quantitative variables, you have the age measured in years, the weight, the present weight, that is in terms of kilograms or pounds, and weight at age 18. We have also variable, value, and observation. So when we say observation, that is the unit upon which measurements are made. For example, that is in terms of persons, place, or thing. And when we say variable, that is the generic thing being measured, like age or the HIV status. And the value, that is the realized measurement, just like an age of 27 or an HIV which is positive. So variable, these are generic. When we say value, that is the specifics, the measurement really of an age. That is, for example, 27 or 18 or 30, or an HIV test result, whether positive or negative. So data collection form could look like that, or sometimes we have our own data collection form. That's very important if you are going to look into some medical charts. So you have to have your data collection form, your DCF, or if you have that survey, you should also have that survey form as your form of data collection tool. Each questionnaire should contain an observation, or each questionnaire contains an observation, and each question corresponds to a variable. So for example, I have this example in US Census form. You have there how many people, so you have a lot of information. Or maybe just like our medical chart, that depends on the hospital or the institution, so they have their own medical chart in which you are going to fill in the basic information of the patients. And the data table, you have like that in form of an Excel. in which each row corresponds to an observation. You have here rows 1, 2, 3, 4 that corresponds to an observation. Each column contains information on the variable. You have age, sex, HIV, the onset, and if it is infected or not. And each cell contains a value. So the cell here contains a value 24. Here on the onset, it contains the value that it is of the 30th of May on 2005. And you have this also cigarette use and lung cancer. That's also an example in which you have cigarette 1930, so that is per capita cigarette use in 1930, and you have there the mortality equals to lung cancer mortality per 100,000 in the 1950s. So this is really longitudinal. So that is an example of a table. Okay, so unit of observation is by region or by states, and it is not on individual. You have to take note also of the data quality. Okay, so an analysis is good as its data. So you cannot have a good analysis if your data is not good. So there is some form of validation, data cleaning. So we have the term GIGO, garbage in, garbage out. So there is data cleaning before doing the analysis, so that the data that you're going to finally analyze is of good quality. There is also validity, freedom from any systematic error. That is why when you're using Microsoft Excel for encoding your data, you need to have some form of validation in it, so that we will avoid typographical errors. That if you are encoding data that is not going to be more than 100, you have to specify that. Sometimes we long press the 1 or the any numeric key, and it's going to appear so many numbers. So to avoid those types of errors, we have to validate that the data that you will be encoding is below 100. Objectivity is seeing things as they are without making it conform to a world view. So it should be objective, your data. And then you have to consider how the wording of a question can influence validity and objectivity. So that's why you have to look at your survey form. If you're using a survey form, if you have worded your question properly. So a good data analysis plan should summarize all these things. Okay, so you have your independent or predictor variables, you have dependent or outcome variables, or sometimes we do not do this anymore. We are simply summarizing them in the Excel worksheet with each variable on each of the columns in the spreadsheet. Now, going back to the aspect of planning your statistical analysis, after having your variables, you have to select now the appropriate statistical method to test your hypothesis or to summarize your variables. So this depends on your research question, or if you have your hypothesis and the type of data, a variable, as I mentioned previously. And you can choose a lot of statistical methods from all of this, your RQ, your hypothesis, and your type of variable. So this aspect of data analysis plan outlines why each statistical method will be used to test the hypothesis. So there is some form of reasoning or some form of rationalization, or you have to defend why you choose that statistical analysis plan. And also you have to mention here the level of statistical significance, the p-value, which is often but not always set at less than 0.05. It should be written that p-values less than 0.05 is considered significant. Why use 0.05? That is the default. So when you are going to use any statistical software, default p-value is 0.05. Then there are also, I have seen that they ask questions if we write p-value less than 0.0001, like that. So there are some confusions, I don't know, but you have to remember always that p-value, the reference is always set, the alpha level is always set at 0.05. And remember also that good analysis plan should clearly describe how missing data will be analyzed. So how will you treat the missing data? If there are missing data because you need to include those patient, but there are some missing data, so how will you treat missing data? There are softwares that are not including the missing data as long as you code it as missing. Okay, so the use of statistical softwares, there are a lot to choose from. These are just a few common. But there is the R, which is not included here. There is Jamovie. So, here, very common, of course, is SPSS. And you have EpiInfo, you have SAS, you have Stata, you have Microsoft Excel. I have come across also MedCalc. So sometimes it's difficult to do meta-analysis using the other softwares, but then MedCalc is helpful, so you can also download MedCalc. For those familiar, for those on epidemiology, so they're using the EpiInfo. And in writing your statistical analysis plan, you have to include the version number. So if it is SPSS version 26, like that, so you have to include the year of release, the author and manufacturer. So, IBM, SPSS, like that. So, beginners have the tendency to try different softwares. Of course, if you are running your own statistical analysis, you can use a lot of this. But then for basic, basic descriptives only, you can use the Microsoft Excel. There is no need for you to use SPSS. But SPSS is going to give you a better view if you're going to do some cross tabulation. Because sometimes it's better to see, although they are mostly descriptives, but it's better to see if it is a two-way or three-way table, because you can get a lot of information. Unlike a one-way that you have this gender, male, female, and the frequency counts, how many males, how many females, and then in the next row you have the BMI, whether underweight, normal, overweight, and obese. But it's important to look at them, whether how many males are obese, how many are not, normal, and how many females are obese or overweight, like that. So that's why it's important sometimes to use a better software aside from the Microsoft Excel, that you can do some cross tabulation. Okay, so there are some examples here, outlines on looking at the analysis plan. So it's good if you're going to have some drawing, some conceptual framework on it, how it's being related, or on your choice of statistical tool, you can always present that. Or this one. Okay, so the nitty-gritty of it, I don't need to explain this one because it is beyond the scope of my discussion here. Then, the creation of the shell tables or the dummy tables. Okay, so Data analysis involves three levels of analysis. Either you are going to do univariate analysis, bivariate analysis, or multivariate analysis with increasing order of complexity. So univariate, that's the one I'm telling you, that you are simply presenting frequency counts of some demographic or clinical demographic characteristics. You will be doing some bivariate relationship if you're comparing now the proportion of males and females who are hypertensive or non-hypertensive. And you do some multivariate analysis if it's going to do a lot of, looking at relationships of variables which are a bit complicated na. And then shell tables should be created in anticipation for the results that will be obtained from these different levels of analysis. So maybe we should refrain from using the word dummy tables, but instead we'll be using the term shell tables, because I have seen this one in an article published. It's a medical research article. Example of tables, shell tables that you're going to create for univariate. Yeah, like that. So you have your variable, then you have your label column. If it is the age, then you're going to have your mean, open close parenthesis SD, or you can have mean plus minus SD. For the gender, you have male, female, and you have the counts and the percentage or the proportion, and the disease present. Okay, so no need for us to write hypertensive, yes or no. So if it is hypertensive, you just have to put in the frequency and the percentage of those having hypertension. This is the one bivariate. Okay, so you have the disease present and absent, like that. Then you have your odds ratio and the confidence, the 95% confidence interval, and the p-value on the last column. That's how it would look like. It's a scientific ethos. According to Peter Medawar, I cannot give any scientist of any age any better advice than this one. The intensity of the conviction that a hypothesis is true has no bearing on whether it is true or not. Okay, so with that, I would like to end this talk. Thank you, and good day, everyone.